Lesson 7-7, compound interest. This is part of simple interest, only a little bit more or deeper. What actually happens at the bank is that you put your money in, they figure the interest, and you get a little bit each day, and then if you leave it in long enough, it really adds up. It's compounded. Compounded. We'll show you how that works in a moment. The basic idea, of course, is simple interest. Interest equals principal times rate times time. I equals PRT. The more you put in, the bigger the rate. The longer you leave it, the more money you have. And the next part is, you don't have to work for it. You can live off the interest. What a way to go. Compound interest works like this. We're going to take the big numbers because it's kind of hard to see this with small numbers. We're going to put in, like, say, 100,000. I know it's kind of hard to imagine that, but if you do your math enough, save enough years, that's the thing about young people. You've got years. Us older people, we don't have enough time. Retirees run out of time. But if you put enough money in regularly, you'll see that here also in another video. $100,000, we'll use 6%, principal times rate times time, but we're going to use it 1 year at a time. Let's say you're going to leave it in there for 20 years. Well, 6% of 100,000, 6,000. You just earned $6,000 by not spending it, by just leaving it in the bank. That's year one. Year two, you don't have $100,000 in the bank. They paid you $6,000. You now have $106,000. And you might say, well, ooh, whoopee, big deal. Well, 106,000 times 6%. I'm going to leave it at 6%. I'm going to leave it at 1 year. Now I know this is the second year, but we're compounding it 1 year at a time. Don't put in 2. It's 1 year at a time. We're just going to do it over and over again. 6,360. You just made an extra $360 because you left it in the bank, and it's compounding. It's compounding. You're earning interest on interest. And what happens is it actually grows even faster. Year 3. Put in, we don't have 106,000. We have a total of 106,000 plus the 6,630. So 112,630. Oh, sorry. 360. Principal times rate times time, done over, done over, done over. I'll leave it at 6%. It's still 1 year. 106,000 plus 6,360 times 6%. 6,741.60. The beauty of the power of a dollar, just compounding. You're going to earn a little bit more each year. Now, if you leave this for 20 years, you can see that if I leave this for 20 years, I got 20 calculations to do. I'm only down to number 3. Principal times rate times time. It's compounded annually. Every year means annually. So you'd use 1 at a time, 1 year at a time. Is that the way the actual banks use it? And the answer is no. They compound it every day. Every day. The computers kick in like after midnight, and then it actually figures the interest. You don't get much per day, but you get some each day and a little bit more. The reason they do that, people are always putting in money, taking out money, transferring money. It's kind of hard to figure it out at the end of the year. Way back in the day, they might figure it at the end of the year because there wasn't too many transactions. Now, with internet banking and people borrowing, depositing, let's do something per day. Again, we're going to have to pick a big number. We'll pick $500,000 to get the idea across to you. Principal times rate times time. $500,000. We'll use 2%. 2% to more like it today. Time. Now this is day 1. Day 1. Principal times rate times time. You don't put 1 because that'd be 1 year. 1 day is 1/365th of a year. It's a fraction. 500,000 times 0.02. Make sure you got 0.02, the decimal. It's not 2%. 2 is not the same thing as 2%. 2% is 0.02. Times 1 divided by 365. You don't need a calculator button that has a fraction on it. 2740 to the nearest penny. 2740. What happens about day 2? You don't have $500,000 in there. You have 500,000, 2740. Yeah, a little bit more. Let me add 500,000, $24.40 times 2% times 1/365th $27. Oh, you know what? With rounding, we didn't get anything. With rounding, it's still rounded to 2740. Day 3. Take the 2740 there, 2740, add it in to the 500,000, 2440. Take that times, take that times 2% times 1 divided by 365. Let's see. Let me recalculate that. 500,000, 5180 times 2% times 1 divided by 365. Didn't pick the right numbers. Oh well. Eventually you're going to gain, and you're going to gain like a penny a day. And you leave it in there long enough and it accumulates. 2% isn't very big. Every day. The trouble is, I hope you can understand this. Let's say you have money in there for 20 years, like that other example. 20 years. And you're going to do this every day. There's got to be a formula. There's got to be a formula that'll just give me this at the end, totally, at the end of 20 years. What about 40 years? Now with computers, it's no big deal. Every day it kicks in. Some days you get a little bit more, maybe add a penny or two. Like the other example, you might earn quite a bit more. Save your money. Put it in the bank. Let it grow. It's called compounding. It depends on the time. Is it compounded daily? Is it compounded weekly? If it was weekly, it'd be 1 over 52. Monthly, 1 over 12. Yearly, 1 over, well, it'd be just 1. But the best thing is compounded per day. It'd be nice to do it per second, but that's too complicated. Every day, earn some interest, save it, compound it, the power of money.